Welcome to the video on torque. It's easy to learn as opening a door. There's three things you need to know about torque, which is our rotational equivalent of force. The first thing, how large is the magnitude of the force you're applying? And in opening a door, you need to apply a force large enough to open that door. Two, what direction did you apply that force? And ideally, when you open a door, you want to apply a force perpendicular to the door. If I try to slide the door sideways, it's not going to open. So the direction of the force, the magnitude of the force, and lastly, the location of the force. I need to make sure I apply a force far from my axis of rotation to produce enough torque to cause that rotation. So let's go to the board and take a look at this. So, torque, easy as opening a door. Three main parts: the magnitude of the force, the direction of the force, and the location of the force. So how do we put that in an equation for torque? So torque is the letter tau. Basically, it's a one-legged pie, and it's measured in newtons per times meters. So what we're going to do is we're going to multiply force times R. Now force, specifically, we want the perpendicular component of the force. And when I talk about perpendicular, I'm thinking about, well, what is the object I'm trying to rotate? And I want to apply a force perpendicular to it. And so that's our perpendicular component of the force. The R is how far is it from our axis of rotation, which we typically denote with a little X like that. How far from the axis of rotation to the location of the force? Okay, so that is our R value measured in meters. So let's give this one a try down here. So I have some door maybe, and it has an axis of rotation at the hinges. I'm applying a force. I'm not doing it completely perpendicular, so what I'll have to do is I'll have to resolve that force into components. Specifically, I'm concerned about this F sine theta component, because the F cosine theta, if I push on a door toward the hinges, is it going to open or close? No, that is not producing any torque. The only part that's producing any torque is that F sine theta. So that is my perpendicular component of the force. R, how far is the force from the axis of rotation? That is just given to me as R. Make sure you don't get confused and try and find out, well, how far is this point from it? This is just a picture of the components of the force. It's not an actual location of the component of the force, okay? So make sure you always go to where that force is acting. And then to get a direction, we use counterclockwise as positive, clockwise as negative. So here, this is going to be rotating clockwise. How I know is I can take a ruler or say my pencil, and I can put my axis of rotation and hold my pencil or ruler there, and I can push like on that force and see which way does this rotate. And so if I push it up, I notice it rotates in the clockwise direction. Clockwise being my negative, so I would have a negative on that torque. Easy as opening a door. Oh, hope no one saw that.